So at this page, I'm going to talk a little bit about things we can do with the data table, the data behind the maps that we're generating. So think of it this way. In your final project, I want you to take a look at what the maps tell you, and then think a little bit about what the data that lie behind those maps tell you as well. So leaning on some of the things we were doing in our look at statistics. Now in this case, that means I'd like to take a look at the data tables lying behind commute times and population density at different scales. So I'm going to go to the American Community Survey from 2019. So that's the 5-year period ending in 2019 that provides a rolling average of those of that span of time. And I'm going to say Begin Report. And what I'm going to do here is show you how I can work at different scales. What I'm going to ultimately do is download all the states in the country, look at the relationship at the state level, and I'm also going to look at all the census tracts in Mecklenburg County, North Carolina, let's say, if I can do that on the fly, and see if those relationships look different. So here I'll start with the state level, and I'll say all states, and this will download a data table. When I say add, that's just all the states in the country. And I'll say proceed to tables, which will allow me to choose the measures I'm interested in. So here I'll say search by keyword and put in population density. All this looks like I've done this before, and there it is. So when I say search, I get population density per square mile, and I say add to table. And then I can add another measure. I can say commute and search for that. And I get average commute time to work in minutes, and I say add. And now I see that I've got 2 measures in my table. And if I show results, I then see that when I download this, I'm going to get all those geographic identifiers that we saw when we did this in the mini project, and a few different measures. 3 that pertain to population density. I'm going to get the total population of each state. I'm going to get the population density, I'm going to get that land area of each state, and then I'm going to get in minutes average commute time. And this will be for all the states in the country, so when I say data download, I can tell it to download it as a CSV file, which I'll do. There it is. Now, while I'm at this, I think I'll also go back. Can I do that? Tables. I'm going to go back and do this again, working with the 5-year estimates. And this time, I'm going to try to get all the tracts in a specific county. So I'm going to say census tract within a state. So I'll say North Carolina. Within a county in that state, I'll say my home county, Mecklenburg. And I'll say all census tracts in Mecklenburg County, North Carolina. There we go, and add that to the table. Then I'll go to the tables and do the same thing I did before. First I'll search for 5-year estimates 2019, and I'll go up here and say search by keyword, and I'll say commute. See what they have. Average commute time to work in minutes. Great. And then I'll do that with population density. And I'll do the same thing I did before. I'll show the results. And so I should be looking at all the census tracts in Mecklenburg County, North Carolina. And it looks good to me. Same measures, right? I've got total population, population density, area land, average commute time to work. Now it's good to remember those or make a note of them, because when I download this table, it won't be as immediately apparent what the measures are, but they're in this order in the resulting table. And so when I download this as a CSV, I'm just going to open it up in JMP and show you a few things that we can do with this table to make some sense of what the underlying data distribution looks like independently of what we see on the map. So here are all the census tracts in Mecklenburg County, North Carolina. First note, there are 233 of them. And I get all these different geographical identifiers that tell me different ways of telling me how the Census Bureau identifies these tracts. But ultimately, At the end of the day, way at the right, or at the bottom of this list of columns, I see these 4 measures. Now this one is pretty identifiably commute time. These others, I can return to the table and look, but what I believe in the table it said was this is total population, and I can change that manually. This middle one is population density, or people per square mile, and this is area of each census tract in square miles. So this is the thing I'm actually interested in. So I'm going to change its name just by clicking there. So now I've got these 2 measures. There are a couple things I can do. First, I'm going to take a look at the distribution platforms of those measures, just like I had you do in mini project number 2. So I'm going to grab population density. If I hold down my control key, I can grab commute time and drag them into this box and say OK, and I'll get 2 distribution platforms. You might be wondering why yours look different from mine. Part of it's because up here at the top I select stack, and I've changed a few other defaults too, but when I say stack I get this sideways histogram instead of the vertical. For whatever reason I find it easier to read it this way. You might notice I get a few other things you don't get. I've customized the view a little bit, and you can do the same. In your case, I would recommend clicking on the red triangle beside Summary Statistics and getting Customize, and selecting some of the things we've talked about, like variance, and the minimum, and the maximum, and the medium, and the mode, and the range, and maybe the interquartile range. Those are all things that you can kind of make sense of. They help us understand skewness and spread. We talked about confidence intervals. We didn't really talk about standard errors, and we did talk about standard deviations. So I think that's the set of things I'm going to keep and say OK. And then I'll get this longer list. And basically all of these things allow me to say, what's the center of that distribution, roughly? What's the typical case? It's a way of thinking about what the center of the distribution tells us. And then how widely do things range off of that typical case? In the case of population density, it looks like it's highly skewed. There are a few really dense tracts in Mecklenburg County, but not really that many. Otherwise, it's a fairly normal distribution. And so these are the sorts of things I'm asking you to think about as you provide a description of the measures you're working with. The other thing you can do, if you're feeling bold, is remember the hypothesis testing portion of our foray into statistics. And so here I'm going to ask the question, is commute time predicted by population density? In other words, if population density goes up, does commute times go up, or does it go down? Or is there a pattern at all? And so to do this, I'm going to put population density in as X, meaning I'm asking the question, do changes in population density yield or cause changes in commute time? And what I'm fundamentally asking here is, do I see some sort of linear trend between them? As one goes up, does the other go up, or does it go down, or does nothing really clearly happen? So I'll say OK, and I get this scatter plot of all of the census tracts. And so I'm going to say fit line. And this tells me what the overall pattern is. It shows me what the overall relationship in my data in these 233 observations is, or 230. And basically, what it's telling me, if you think back to what we said about hypothesis testing, is this doesn't tell me a whole lot. I'm looking right down here at 0.1491. That's the thing that's telling me, is the relationship between these two things something other than a flat line? So I see a slope line in the results, but is it a big enough difference that I think out there in the world, among all populations, among all census tracts, that I would see this relationship? And it says I've got a 0.149 probability of seeing this in a random sample, if the null hypothesis were true. So pretty good chance. Cannot reject the null hypothesis. And here the null hypothesis is no relationship. These two things have no relationship to each other. So even though I see a pattern, I can't really quite trust that pattern. Not at this scale. Now, I'm not necessarily asking you to use this tool, which is called regression, because we haven't really talked about it, but this would be the logical next step, given the structure of the data I'm working with. I'm happy to help you think about how you might turn this into an actual hypothesis test. What I'm asking you to do fundamentally is start with the description. What do you see? What does the pattern look like of these two variables? And then what do you see when you look at these two patterns mapped? Do you see a different sort of correspondence between them, or does it just seem kind of random? And one way of gauging that is by looking at an actual hypothesis test in JMP. That's not the only way to evaluate this relationship, though. So that, in a nutshell, is what you can do with the data behind the data you get in Social Explorer that can allow you to do a deeper dive into the relationship that you're looking at. Now, I would do this at the track level, and then I'd repeat these steps that I've done in JMP, maybe looking at all the counties in North Carolina, or perhaps all the states in the country, to see if the relationship is the same, if the distributions look the same, and then if the basic relationship between the two of them looks analogous or similar. And that would be sort of an exhaustive look at two phenomena at multiple scales.